Hi everybody, and welcome to the Inventor and 3D printing tutorial. Today we're going to be talking a little bit about 3D printing and how it works, as well as how to do 3D modeling and using the Autodesk Inventor software. Right. So first off, 3D printing is what's called an additive manufacturing technology. This means that when we're building something, we're not taking material away from it like you might do when machining a aluminum block into some kind of part like an engine block or something like that. We're not removing material, we're not cutting away, we're adding material onto some kind of base to build up an object, right? And the way that 3D printing typically does this is through layers of material added over computer control. So usually what happens is we have some kind of extruded plastic or some kind of powder that gets fused into the shape that we want, and a computer controls where this fusing happens, where this material gets laid down. This makes it very powerful to design things and build things that would be impossible otherwise, right? There are things that we cannot do through subtractive manufacturing, through machining and casting even, that we can do using 3D printing. But there are also some things that we can't do because 3D printing typically makes weaker material properties, though this can be overcome with secondary manufacturing processes based on the 3D printed objects. Overall, it's a really powerful technology, and it's used more and more because the price of making these things has come down so much. So one thing that this does require that is different from typical manufacturing methods is that it requires three-dimensional design. So when we're developing a 3D, something that needs to be 3D printed, it needs to be specified entirely in the 3D modeling software so that the computer can manufacture it. Typically, what previously would happen is we would design some mechanical drawings that are two-dimensional, and a human would reinterpret them as a 3D model. To do this 3D design, there's a lot of different options out there. For us at ASU, you can go to autodesk.com/educationhome, and as students, you can download some free software. So if you're a student at ASU and you have an ASU email address, you can download the most recent version of Autodesk Inventor, which is what we're going to be using, for free for 1 year, which is super cool. So go ahead and do that. That's the software we're going to be using. So if you want to go do that right now, please do. If you don't want to do that and you want to use some other free software, Autodesk 123D is a sort of light version of Inventor. It's also extremely powerful, so you can learn to do a lot of the same things we're going to talk about today. SolidWorks is another option, though it's not free. That's made by Dassault Systems, but it is also very powerful and works in a similar way. OpenSCAD is a way of mathematically representing three-dimensional objects that you can use to design 3D objects. And Google SketchUp is also free, and there are some extensions that allow you to do 3D printing from there. So there's lots of different options. We're going to be focusing on using Autodesk Inventor today. Before we get into the 3D modeling itself, we want to talk a little bit about mechanical drawing, right? So mechanical drawing is about representing all of the information that's necessary to accurately and repeatedly manufacture an object, right? So this is mechanical drawing came from the time when an engineer would have to communicate to a craftsman about how to manufacture something. So the engineer would design it, they'd figure out all the mechanical constraints and all the stresses and all that kind of stuff, and give that information to a skilled machinist who would turn that information into an actual part. So the engineer often did not actually build anything themselves. They would just have someone very, very skilled in manufacturing do it for them. This way of representing this information is still around, and it forms the foundation for how information is expressed to the computer, in this case, for designing three-dimensional objects. So one of the things we need to talk about is how we represent three-dimensional objects in two-dimensional views. Right? So one of those things is what's called a projection. So here we have a three-dimensional object right in the center here, and we have three different projections of that object. We've got a front view, we've got a side view, and we've got a top view. So this is you can think of this as a sheet of paper where we've drawn a picture of what the object looks like if we were to look directly down on top of it. Same for the front view and the side view. And you can see by combining these three views, we can actually represent the entire object. So we just kind of open up the box that would be a projection around it, and this constitutes the mechanical drawing. This is all well and good for representing the general shape, but a machinist and the computer itself needs to know the specific sizes of these features. Is this thing an inch wide or is it a foot wide? Right? That kind of thing. So we need to add some dimensions to these things. Some of the other conventions that we have for how we represent this information is the line types, right? So a heavy line or a light line represents physical objects, the physical sort of boundaries of the object. Hidden lines represent something that is behind what we're seeing. So if we have a hole in an object and we're looking at it from the side, that hole might be represented by some hidden lines. Center lines are for guides, so this is where we would represent where the center of a hole is, or the center of some kind of geometry. Dimensions are represented looking like this. We'll talk about those more here in a minute. And here are some good examples, right? So here's an object. We can kind of see that it's a little square with a notch cut out and a hole in the middle. So we've got center lines here. These heavy lines represent the outline, the physical outline. And looking at it from the side with a section, so this is cut down the middle. That's what this this pink line here is it means we're cutting down the middle and looking at it as if we were cut, right? So there's a open area here. This is the place where the cutting would happen, stuff like that. So we're kind of getting a view of the inside. If we're looking at it directly from the side, you can see there's some hidden lines here and here. These two hidden lines represents the sides of the hole, and this hidden line represents this the sides of this cutout that happened right here. Right? Same thing from the side view, the other side view. So this would be the front view, and this is the side view. We can see the hole here, and it looks like we're looking at the bottom of this object. So as if this end were turned towards you, that's what we're looking here. So we're looking at the bottom of the object facing you, these two little nubs, and the hidden lines in the center line for the circle. This is what the object would look like in real life, and this is the mechanical representation of it. Our dimensions represent the information necessary to recreate all of the features here, right? So here we have a little electric motor and all the dimensions that we would need to remodel this motor, to manufacture this motor, or to build around this motor. So it's very important that these dimensions are correct and that they're clear. So because the machinist or the manufacturing company is going to have to build what you specify, and they have to know exactly what it is, right? And you'll notice that there's a lot of numbers here and there's a lot of arrows and stuff like that. Somewhere on here, either these units themselves will have the millimeters mark, it'll be mm, or somewhere on the sheet it'll say millimeters. So we know that all the units here are in millimeters or in degrees and stuff like that. So the first kind of dimension we're going to look at is what's called linear dimensions. And linear dimensions just represent length. They always start with some kind of anchor. So these anchors are the lines that go in between, and the leader, which shows us where the extents of the dimension are, and there's always a number on it. Right? And the number isn't always centered. Sometimes it's offset. Sometimes we have one like this where the number is too big, so it's going to pop outside. So this 1.6 represents the distance between these two arrows that are outside the anchors, and that's how we represent those. We also have diameter dimensions, so these are much like linear dimensions, but they might be something like this, where it's a single leader pointing to a hole or a circle, and it represents the diameter of that object. And there's also notations for how many, so we don't have to note every single one. We just say that this one is the same as that one, and that makes a lot of sense. Same thing here. We've got a little zero with a slash through it. That means it's a diameter. If it's missing that, it's probably representing the radius. Right? And we also have angular dimensions. So here we've got some kind of baseline for which the angle is measured against, and then we've got another anchor and the leader that represents what the angle of rotation is for whatever object we're representing. In this case, it's the rotation of these pins, these connections from the center of the body, from the axis of wherever it's being mounted. Without further ado, let's get started designing some 3D models in Autodesk Inventor. After you've installed Autodesk Inventor and opened it up for the first time, you should see a screen that looks like this. Now in this case, we're going to start a new part. And there's a lot of different capabilities for Autodesk Inventor. I'm going to focus on the most basic creating individual parts. But you can do things like create whole assemblies, combine parts together, constrain them mechanically, test out how they work together in a simulated environment before you do that. You can use part drawings, part designs to generate drawings. You can also generate presentations and videos, all kinds of amazing stuff. I'm going to focus on the most basic part, but there's a lot of tutorials, fantastic online tutorials and tutorials built into the software that you can and should follow to get an idea of all the different kinds of capabilities. It's an immensely powerful program. I highly recommend it. It's super cool. Back to creating a simple part. So the first thing we want to do is click on New Part, and we have our blank modeling space, right? So in this space, we want to do a couple of things first. First, we want to go to Tools. We want to go to Document Settings. And we have a bunch of stuff about lighting here, but really what I want to do is focus on units, right? So units are super important because when we represent these things, the numbers that we use to represent them have to agree across all of the systems. So when we're designing something, you want to make sure that you design something using the correct units or something, or that you convert between them. So in this case, I'm going to switch to actually millimeters. I like millimeters better for designing small parts, and it typically interfaces with 3D printers a little bit simpler, so it's a little good there. Go to Sketch. So when I'm drawing, I probably want my snap spacing to be 1 millimeter for both of these. 1 millimeter. And a major 2 snaps per minor, so that's every 2 millimeters, and we'll make it a major line a major snap every 10 minor lines. So my big lines are going to be on every centimeter, and my little lines are going to be on every other millimeter. So we'll be able to see that here in a second. Hit OK, hit Apply, and hit Close, and we're going to start a new sketch, right? So we're going to go back over here to the Sketch tool, and we're going to start a 2D sketch. Now this is why I wanted to talk about mechanical design, because basically in Inventor, a 2-dimensional shape builds the foundation for a 3-dimensional object. So we're going to use all of those 2-dimensional mechanical drawing skills to build up a 3-dimensional object. All right, so we're going to start with a 2D sketch here. And what Autodesk first does is give us a choice of planes to work in. So these are what's called a work plane, right? We've got the XZ plane. You can kind of think of this as working on a tabletop. And we've got the XY and YZ planes. And these kind of are like working on a wall, right? So it's kind of, this is what a normal tabletop would be, and these are the walls of that. I always like to start with the XZ plane, but you can pick any one of these. All right, so now there's that one, and it gives me an origin. So this is the 000 point in the world, and you can kind of see that there are some coordinates and stuff down here. And the most basic things that we can do is start drawing some geometry. So the first thing I'm going to do is start with a rectangle, right? Really simple little rectangle, and I just click on the origin, and it gives me an idea of how big this object is as I'm dragging it around, right? So right now I've got a 10.136 millimeter by 7.518 millimeter sort of rectangle. I'm just going to drop that anywhere because I'm going to add some dimensions to this to make it really precise. So it's just a generic rectangle. Now I'm going to turn it into a specific rectangle. So I'm going to click the dimension tool, and I'm going to click on one of these edges. You can see it's a linear dimension. And when I click on that and pull it down, I'm not dragging, I just clicked it following my mouse and pull it down, it gives me a nice little dimension thing, and I can actually set the dimension. So in this case, I'm going to make it a nice even 10, and that actually changed the geometry for this shape. And you can see that it changed from a green line to a purple line. And that means that this design, this line, these lines are constrained, are anchored based on this dimension, right? This one is still out there, so I'm going to click on this guy and give it a dimension, and I'm going to change this one to 5, right? And you can see that changed the geometry as well, and I can change these as many times as I want, so I can play around with how big things are, stuff like that. And the idea is that every design feature in your model should have one of these dimensions, so that if you have to change it later, it's easy to change and everything kind of works out really well. I'm going to kind of get zoom in here a little bit. So I'm going to use what's called the zoom all, and basically it fits our geometry onto the screen. So it kind of zooms in a whole lot. I'm going to back out a little bit here using the zoom on my mouse. Go away. And we're going to start changing some stuff. So what I want to do is I want to add a few little features to this. I want to kind of round these corners off. So the first thing I'm going to do is I'm going to pick this circle object, and I'm going to drop it out here. See, it's already doing really cool stuff for me. Like it gives me suggestions on where the middle line is. So there's one there. You can see it's at the -5 millimeter mark on Y. And this one, you can see it's doing the same thing over here. It's doing 2.5 on that side. So I'm going to start mine out here somewhere. I'm going to run up to that part. Right, so I draw my circle there, and you can see I just started at the center and clicked again on the edge, and it anchors it there. I'm going to give this guy a dimension, 5 centimeters or 5 millimeters. That looks great. And I'm also going to give the middle a dimension at 2.5. So that'll put one edge, both of the edges on the box here, right? So we've used the rectangle tool, we've used the dimension tool, we've used the circle tool. Now we're going to use something called the trim tool. And this allows us to combine some of these shapes and make some really cool behaviors. The trim tool is this guy right here. And basically what it allows us to do is to trim away geometry after the intersection of two other pieces of geometry. Right? So check this out. I select the trim tool, and as I hover over pieces, they turn dotted line, right? And that means that if I click there, that part is going to go away. So I click on this one, and the geometry gets cut back to wherever the last intersection was. I'm going to do the same thing here. I'm going to do the same thing here and here. And now I've got a nice outline curve, even though my angle represents the diameter here. This is just a geometry line, so I don't have to worry about it. But the physical outline is now curved on this side, right? Now, that's a really easy way of combining geometry. I can also kind of do a shortcut. This is what's called a fillet, right? So a fillet is just a curving, a rounding procedure that happens on square things in mechanical systems. So there's a special tool. It's so common, there's a special tool for it. So here I'm going to do this one. I'm going to give it a 2.5 millimeter radius. I can pick the two lines, or the corner, and it gives me a preview of where the fillet will happen. I just do that guy, and it happens easy peasy. So I've done the same thing on two sides, right? I've got this one I did using a circle and cutting it away, and this one I did using the geometry tool. And you'll notice that it gives me a nice snazzy dimension thing here. We'll just zoom in to see everything. Right, so this is the first piece that I wanted to make. And you can see I've got a bunch of different ways of viewing it over here in the corner. So if I ever want to exit a tool, say I'm in the circle and I want to stop using the circle and I just want to start like moving things around or something like that, I can hit escape on my keyboard and that exits all tools, and I can pick something else, or I can just start highlighting things and dragging them around. That's a good one, so I'm going to say finish sketch. And now I'm back in the 3D view, right? So you can kind of see that this is a sketch, a two-dimensional sketch on a three-dimensional surface, and I can look at it from all different ways using what's called the orbit view tool. So I can spin it around and see where it's situated in space, all that kind of stuff, right? And if I want to go on the outside, I can rotate it. Clicking on the inside allows me to pivot it around the origin. And I've also got this guy over here, which is sort of the box view. I can click and drag on any one of these corners, or I can click on a specific one and it brings me straight to it. I click on that one. It's an isometric view. I can drag it around, do whatever I want, right? Now, I want to turn this two-dimensional surface. It has no thickness whatsoever, right? It disappears when I look at it from the side. I want to turn it into a three-dimensional object. And to do that, I'm going to go to the 3D modeling tab, and I'm going to do what's called an extrude. And what the extrude does is it takes a two-dimensional surface and sweeps it along a perpendicular axis so that it makes a three-dimensional object, right? I get to set how far it goes. So in that case, there was only one profile, one solid outline available, so it auto-picked it for me. But I have a bunch of options here inside the tool. So I can choose the profile that I want to use, which is the one that's already selected, and I can do a bunch of different things with it. I don't have very many options right now, but we'll use it again here in a minute and show you everything. But my distance, how far I want to go, I want that to be 5 millimeters instead of 10. So I can say how far I want it to stretch, that kind of thing. Right? So there's one right there. And now I've got a real three-dimensional object, right? It's pretty cool. It's a whole little block thing here, right? Now it's not very useful. It's just a little block, but we need to start adding some features to this, right? So I'm going to rotate around here to the back side, and I'm going to start a new sketch. So I'm going to go to Start 2D Sketch, and I'm going to click on the back surface. So this is the bottom of the object that we just created. And what this does is it moves the whole thing and allows me to create a new sketch on the bottom of this thing that we're going to use to do more extrusions here in a second. So I'm going to use the rectangle tool again. I'm going to pick these guys. So that locks at 5 millimeters. I only want to do, let's say, 1.5-ish there, right? I'll do the dimensions again, not that one. There's that guy. That's the one. There's that guy. Do that. I want to do the same thing, so I'm going to create a new rectangle down here in the corner. Same 5 millimeters. Now what's cool, so I can do dimension here, do that, and I can, instead of typing something in, I can select it there. So I can actually say, I want this dimension to be the same as whatever that dimension is, right? So I can hit OK. Now it says it's fixed at 5, or it's a function of this one right there. So I'm going to do the same thing over here and set it equal to that guy. And that changes all these things. So this is a way of mirroring or making a design parameterized. So I can change this, say, I want this actually to be 4. Both of them will change rather than just one, right? I want to keep that at 5 because we're going to be cut in half, stuff like that, right? And we can also do things like, what's really cool is I could do something like, I want it to be as big as this dimension divided by 2, which makes it half. Right? So there's all kinds of cool stuff. That makes it really easy to have one set of parameters that control the geometry of the whole object by their mathematical relationships, which makes it really easy to resize things and stuff like that if they have some kind of nice constraint relationship. All right, so there's that guy. So that's the end of this sketch. We're going to finish that. And now to do something with these this new sketch, I'm going to do extrude again. I'm going to click the profile object. I'm going to click the inside of these two rectangles. So the first one, you can see it kind of lights up a little bit when I hover over it. So I'm going to pick that guy, and I'm going to pick the other guy. And you can see they're extruding out another 5 millimeters just like we did before, but that's not what I want to do. This time I actually want to, instead of creating new geometry, creating new solids, I want to take away, I want to cut away new solids. So in that case, I'm going to use the cut mode of extrude here, and that's going to reverse it and cut through the other object that I had here. Right, so you can see now I'm getting a preview of where it's going to cut away. So it's going to cut away all of this extra material here in this red box, right? And when I hit OK, it all disappears, right? So now I've got a little bit more complex shape, and this would have been really hard to do in one single sketch. So this one allows us to do something really similar and simple, right? So last little bit is I want to create one more sketch on here. I'm going to put a circle in the middle. Dimension it. Just like that. Finish the sketch. I'm going to extrude it again, cutting through. So I just drilled a hole in it. That's pretty cool. And now, think about this. If I wanted to round, this is a pretty sharp corner. If I wanted to round off this edge, I would have to figure out how to, like, particularly during this curve, how to kind of soften this with a bunch of sketches. Now that's really hard to do. So what's snazzy in this 3D modeling system is that there's also such a thing as a 3D fillet. So I can click on fillet, say I want my radius to be, we're going to call it just half. We want it to be 1 millimeter. And I can go along and I can click an edge. This is one continuous edge, and it'll show me what it's going to cut away to round that off, right? And I can hit apply to do that one. And let's rotate around to the other one. Hit escape to click that guy. And that takes it away, right? So now we've got a nice, rounded, pretty, sort of robot fingertip thing, right? Which is pretty cool. And now I've got, this is my 3D model. I can do all kinds of other stuff. I can add new geometry to it. Whatever you can think of, you can do in this program. It's really, really powerful. So the last step is to, look at the isometric view there. So the last step is to export it in a format that the 3D printer can use. So to do that, we're going to go over here. We're going to save it first as part 1. That sounds good. Save it first. And then I'm going to go here and I want to do export to CAD format. And I want to select the STL file. And this is a generic geometry file. And basically what it allows us to do is to export the raw geometry of the object in a format that basically any 3D printer can read. Now what's important about this one is the options. We want it to be in binary. The units should match whatever we generated there. So if I pick centimeters here, every 1 millimeter in this thing will show up as 1 centimeter in the output object. So I want to make sure that I represent my units in millimeters. I want a high resolution, yada, 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 all that kind of stuff. And then all I have to do is hit OK, and then save it as part 1. And then I can go to the 3D print lab or wherever the 3D printer is with this file, this STL file, and print out my object, right? And always make sure that when you go that you know how big your object should be so that when you're previewing the 3D print, it can work for you. Okay, so let's save it. Okay, now that we've seen some basics for how to do 3D modeling, we need to talk about how to design objects for 3D printing. Now, 3D printing is a bottom-up design process, and we need to remember that it's a physical design process and there are some limitations. The first one is that the printing resolution is usually around 1/100 of an inch or 1/4 of a millimeter. So this means that features on our objects could be either, if the system rounds up or rounds down, by 1/4 of a millimeter. So if we're on a border in between there and it's something finer than that, more material or less material could exist. So for instance, if you have a hole that's less than 1 millimeter and the system happens to average, out to round up on both sides of that hole, the hole as designed would be 1 millimeter, but it might actually show up in your system in your 3D print as 1/2 millimeter because the two sides of the hole get averaged in from the outside, right? So watch out for that. Basically, features less than 1 millimeter run the risk of just barely existing or getting eliminated entirely in translation, right? The other thing is that remember that the 3D printing is a bottom-up process. So that means that arch features, things that hang out into space like this horse's leg or this big ball here, as it's printing, all of this stuff is fine as it's coming up, right? We've got a big base here, we've got this archway. It can stand on things below it when it's being printed. But without these little supports here, this when it starts printing the bottom of this ball, it's printing out into empty space. So there's no way that that's going to work. It's just going to extrude the plastic and it's going to fall out into empty space and not work. So what happens is the supports, these little arms, they call them sprigs, get added automatically by the software. It can tell when it's going to be printing out into space, and it gets added automatically by the software, but these little sprigs have to be removed manually. You have to cut them out and clean up your 3D model so that they don't exist anymore. right? So try to design and save print time and save print material by designing so that things can lay flat and you don't have to worry about big archways and stuff like that. You can see as long as there's a little bit of support, even if it's a pretty straight up thing, or if there's a little bit of an overhang, it doesn't need that support. It can kind of build out to it. But there are some particular instances where it needs extra room, extra support to do that. So try to keep your design simple so that that doesn't have to happen. Now, if you want to try this out, you can take your 3D designs to the Fulton Schools of Engineering 3D Print Lab. They have really reasonable rates. They have both laser cutters. It's at the ECF building across from, it's in ECF across from the tutoring center in the Breezeway. They've got really good hours. They have both MakerBot 3D printers. They both have laser printers, MakerBot 3D printers, some more expensive ones, all kinds of stuff like that. They have really excellent rates. It's very reasonable for material, but it's free if you bring your own material. So if you bring your own plastic filament for the MakerBots, or you bring your own plastic or other materials for the laser cutter, you can do that. If you want to take advantage of this service, you get one free 2 cubic centimeter print with today's workshop. Just mention that you're doing this for class. It's Dr. Muth's class, and you can take advantage of this through the school. This little tiny print. So build a keychain or something like that. Get used to it, and we'll see you on the flip side.